Hello everybody, I'm Roman Rodriguez and we are on propagation and reflection of light. Today we'll be discussing about spherical mirrors, its types and the images formed in a spherical mirror. So, as you know that spherical mirror is a mirror that has a shape of piece cut out of a spherical surface, and there are two types of spherical mirror, concave and convex. Now you can understand it this way that take for example an orange. Now when I peel the orange peel is concave and the fruit inside is convex. So you have two types of spherical mirrors, concave mirror and convex mirror. Now concave mirror is also called converging mirrors, uh, and the use of concave mirror we will be discussing it in the later part. Uh, but just for your knowledge, I mean, you should know that the concave mirror is used in shaving mirrors, or even by dentists and even in telescopes. So basically, concave mirror is a converging mirror, and convex mirror is called a diverging mirror. And convex mirror is used in various parts of car mirrors, and also as for drivers as blind spot. It's also called the fisheye of diverging mirror. So we'll be discussing the use of convex mirror in the later part and the images formed in a convex mirror. Now, the structure of spherical mirror, whether concave or convex, just remember that here you have A, which is the pole of the mirror, and there's an imaginary line drawn, which is called the principal axis. Okay, this is exactly passing through the center of the mirror. Then you have the point C, which is the center of curvature, and this point is of C is at on the principal axis, and the distance between point C, the center of curvature, and the pole of the mirror is denoted by R, which is your radius of curvature. Okay, and then you have the principal focus or the focal point F, and the distance between the focal point and the pole of the mirror A is your um, focal length. It's called the focal length, right? So these are the different points of a spherical mirror that you need to know: the focal length, the center of curvature, and the pole of the mirror, also the principal focus, and radius of curvature. Radius of curvature is the distance between the center of curvature and the pole of the mirror, and the focal length is the distance between the principal focus and the pole of the mirror. Now, the images formed by spherical mirror, just remember that when a ray of light is passing through the center of curvature, it traces back, reflected back along the same path. And when a ray of light hits the pole of the mirror, it reflects at an angle, just like of obeying the law of reflection, that angle of incidence is equal to angle of reflection. You could say the ray of light that strikes the pole of the mirror, and the principal axis acts as a normal, and this angle uh, between the ray of light which strikes the pole of the mirror and the principal axis is your incident ray, and the reflected rays, when it strikes, it reflects back at the same angle, and the angle between the reflected ray and the principal axis is your angle of reflection. So they are both equal and they obey the law of reflection of light. So this is what you need to know, and remember, when a ray of light strikes the mirror, the spherical mirror, at any point, it always passes through the principal focus. Now, the ray diagrams for a concave mirror, basically we'll be doing the 6 cases over here. In other words, 6 possibilities where the images are formed. We'll be moving the object from infinity then to point beyond the center of curvature, then at center of curvature we'll be moving it between center of curvature and the principal focus, and then we'll be taking it between the principal focus and the center of curvature. So all these different cases we'll be discussing, and the images formed in a concave mirror. Let's take the first case. Now, a ray of light is passing through the infinity. The object is placed at infinite position. So where will the image be formed? The image will be formed at principal focus, and this image is very small. It's highly diminished, and it's real and inverted. And when the object is placed beyond the center of curvature, you can see over here the ray of light passes through the center of curvature and it traces back, or even if we had to hit the pole of the mirror, it will reflect back at the angle. So This ray, which passes also hits through the spherical mirror and passes through the principal focus, they'll all meet at the point between the center of curvature and the principal focus. And this image you can see over here is small in size, it's diminished, and it's real and inverted as well. So when an object is placed beyond the center of curvature, the image is formed between center of curvature and principal focus, and this image is small in size, it's real and inverted. Now the third case is when we bring it at the center of curvature. When the object is placed at the center of curvature, the image is also formed on the same side, on the center of curvature, but this image will be of the same size and inverted. Okay, it will be a real and inverted image of the same size. So I guess it's simple, like when a ray of light uh, passes parallel to the principal axis, always pass through the principal focus, and you can see the other ray where they meet, and there the image will be formed. So when an object is placed at the center of curvature, the image is also formed at the center of curvature. This image is inverted, real, and of the same size. Now, the image is formed by spherical mirror. Just remember that when a ray of light is passing through the center of curvature, it traces back, reflected back along the same path. And when a ray of light hits the pole of the mirror, it reflects at an angle, just like of obeying the law of reflection, that angle of incidence is equal. Hello everybody, I'm Roman Rodriguez, and we are on propagation and reflection of light. Today we'll be discussing about spherical mirrors, its types and the images formed in a spherical mirror. Finally, when the object is placed between the principal focus and the pole of the mirror, as you can see over here, then the image is formed behind the mirror. It's an enlarged image, but it's not real, it's virtual image and it's erect. So we don't get an inverted image, instead we get an erect virtual image and an enlarged or magnified image behind the mirror. So now we discuss ray diagrams, for a convex mirror, how the images are formed. There are basically two cases over here: when we place the object at infinity, at infinite position, and the other when we place it between the pole and the principal focus. And when the object is placed beyond the center of curvature, you can see over here the ray of light passes through the center of curvature and it traces back, or even if we and when it is placed in the point at the between the principal focus and the pole of the mirror, the image is you can see over here is diminished and virtual, and it's an erect image which is formed. So the use of spherical mirror, first let's discuss convex mirror. Convex mirror, as mentioned earlier in the introductory part, that it is basically used in cars, okay, which helps us to see the way behind the car. Also uh, in the ATM banks, customers can check that somebody is behind them or not. And concave mirror is used in the headlights in the car, shaving mirror, and dentist mirror as well. So with this we conclude this topic on spherical mirror. So I hope it's clear to you all. Thank you very much.